little bit more understanding about how automation works. All right? So we're going to go over a few definitions first. PLC, what does that stand for?
Programmable logic controls.
What does it do? What does it do?
It basically transforms a signal from one spot to another on a command that's programmed in it.
It stops or starts your action to whatever it's hooked up to.
Oh, yeah, all right. It's the computer that puts everything into motion. It's the computer that turns things on and off. It's the computer that tells things how fast or how slow to go.
More or less a processor.
It's a processor. All right. Now, when we go out, everybody has seen our PLCs, have they not?
Right.
Seen the different kinds. You have different brands. You have Easy PLCs, which we have. We have Allen Bradley's. You have Siemens. You have Hitachi's. There's so many different ones out there, but they all work the same, and they all work off the same ladder logic. Okay. Any PLC program is going to look like that. Okay. When y'all go look at drawings, or when y'all see those of us that know how to read them look at drawings, this is Greek to y'all. But I'm fixing to explain that to y'all, to where y'all at least have somewhat of an understanding. You're not looking like a deer in the headlights, or it's not to where it's so far out that you feel like you don't know what we're talking about. I'm trying to reel y'all in so that y'all can understand more about what we are talking about and what we're looking at. All right? Well, let's go back to the PLCs. Y'all notice a difference here?
Yes.
Mm-hmm.
All right? So, this PLC is called a rack. It's expandable. You can add cards to it, take cards off, do whatever. That one is not. That one's just a block. And this is predominantly what we have. We have these on the N8s, and we have them in the processor, in processing. I think that's the only place we have them. On all your casers, all your palletizers, all that, well, no, your palletizer has a slick. Your wrappers will all have a brick. Okay? What do we mean when we say IOs?
Yeah,
When you
but
hear
now-
somebody say,
In and out.
we gotta go check our IOs out, what does that mean?
Input output.
Input, output, which is what?
In input data, whatever, and the output.
Well, in a more simpler term, is PLC lingo. A PLC works off of inputs and outputs. Without inputs and outputs, a PLC is dumb. Okay? It's just like a computer. If you don't put a program in it, what's it do?
Just sit
No.
that way.
Yeah.
Right? So, over here on a rack, all PLCs start out number 0. All PLCs. All right? So when I say input 9, which connection is that going to be on a card?
The ninth one in?
Where's the 9th one in? So you got 10 dots, you got 10
It's gonna be the
connections.
last bottom one.
It's gonna
You
be
got
on the
10 connections, So
zero,
where's it gonna be?
Bottom.
bottom of
Well,
zero.
this is the ones where it's got 'em, where it's 5 and 5, you know what I mean?
Yeah, but
Okay.
never still your inputs would be in the same place.
Yeah. Be the last one on that card.
Why is it the last one?
Because it's in order, top to bottom.
We start with number 0. So, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay.
Everything in a PLC starts at 0, guys. So, we have 1, 2, 3, 4, 5, 6, 7 slots. Do y'all see that? Okay. Do we have 7 slots or 6 slots? I just counted 7.
7.
Well,
There is 7, but that other one's your main one.
So 6 slots and 7,
Let's count them off. What is this one?
0.
What is 0? Why don't I have connectors on 0?
That's what, the line voltage coming in?
Nope. What's the very first thing you have to have on a PLC? We've talked about it numerous times so far already in this conversation. What is always the first thing on a PLC?
Input?
No, your processor.
Starts with a P.
Processing.
It's your computer.
Yeah.
That's your processor. And it is always, always in slot 0. Okay? Now it's 1, 2, 3, 4, 5, 6, not 7. I'm pushing y'all on this because you need to understand that when you look at ladder logic, or when somebody says, hey, I need you to go, now if somebody says I need you to go to slot 1, terminal 5, and tell me if there's a wire on it, you don't even know what you're looking at. So if I tell you to go to slot 1, terminal 5, you're going to go to slot 1, 0, 1, 2, 3, 4, 5. Okay? Now, these over here, it's simply going to be input, however many channels you have. It's always going to be input 1. It's always going to be output 1. So this one, it could have 28 connections on there, and it's going to read output 1/28. That's the address. Now, let's put it into relative terms. When you're looking at drawings, all right, and you're trying to figure out if you're getting an input or an output because something's not working, right?
Mm-hmm.
You got to figure out what's driving that. So, before we get to here, somebody finish this.
Reaction.
Very good. That's not just in PLC automation. That's in everything we do. If we turn a wrench, what's the reaction?
With looping.
We're either tightening or loosening the bolt, are we not?
Mm-hmm.
We're turning a screw. We're either turning it in or turning it out. For every action, guys, there's a reaction. We need to think about what the reaction is of what it is that we're doing. If I'm over here making an adjustment on a drive belt, like we're out on the floor in the vault, right? We keep the belts loose so that we can slip them things instead of tearing stuff out of the floor, right?
Right.
So if I'm loosening that belt, what's the reaction of me loosening that belt?
It'll wear out quickly.
No, I'm not.
Well, it's where it will slip to not tear up stuff.
There you go. So the reaction is slippage. The reaction is to slip to keep from tearing up the
Right,
equipment.
more stuff.
Right? However, if I tighten that belt up, now what's the reaction?
It can tear up shit.
Now
Just
instead
don't
of
pull
slipping,
everything
it's
out the
gonna-
floor,
It's gonna
yeah.
pull it out of the damn floor.
Yeah.
Now, like, but if you use that like in different technologies, back, we'll say when we, like our vehicles where we had multiple V belts,
Yeah.
if you had, if you run them too loose, then like if it's going to the alternator, it might not charge
May not charge up.
or go to the place.
Okay? For everything we do, there's a reaction. And it goes back to even what we do, what I'm doing now. What is our brain?
Computer.
Our brain is a processor.
PLM.
It is a processor. And we have to think for our brain to react to give us an action. I think I want to walk forward. No, I want to step backwards. It's all relative, guys. Everything we do in our lives is a reaction of our actions. Everything we do. All right? Think about that when you're out there working on the lines, the fillers. You know, N8s are a great thing to think about, because when you're down here, you got top seal issues. Your top seals are right there at the discharge. Does that mean that's where your top seal issues are at? It could be that we need to make an adjustment way back here in order for that top seal to appear. So our reaction that was back here made a difference way up here. Right? Think about how that action of what you're doing is gonna react to what's the outcome's gonna be. Understood? All right? So the same thing here. All right? In order, in this case, an action is what?
Command.
Very good. All right. What is that? Everybody's seen this. They've seen it on TV. Has everybody watched The Matrix?
Mm-hmm.
Yeah,
That's the
And has everybody seen this scroll across them lines when The Matrix is?
What's it called?
Inputs and outputs.
No, but there's a term for it. The
Yeah.
zero, ones and zeros. It's oh man,
What is that?
digital.
digital.
Is that
So
the
what
Analog.
is digital? That's what it is. It's digital. What is digital, guys? Simplified. What is
ones and
digital?
zeros? Don't get no simpler than that.
That's digital. That light switch is digital.
That's off and on, that's digital. Well, what's analog then? Oh, I guess you don't get to that one next. Digital and analog.
Digital is on and off, guys. Simple that. It's a light switch.
Okay.
On and off. That's digital. That's ones and zeros. Right now you're at 1. Now you're 0. 1, 0, 1, 0.
Oh,
That's a digital
cool.
signal, guys. So whenever you hear people talk digital, that's simply all it is. Now, it just means it's on and off. How many things do we have out there
Sorry,
that are on
binary.
and off?
Oh, I was racking my brain. Binary.
Binary is something different.
Oh,
Binary is something
That's
different.
binary code you're thinking about.
So what do we have out here on our lines that are inputs?
The, polarized.
Photo eyes. Is the photo eye not on and off?
On
You either block it or unblock it.
Mm-hmm.
The ones and zeros. Limit switches that we have out here on our chains and our palletizer.
Same thing.
Off
Same
and
thing.
on,
It's
yeah.
either on or it's off, guys. It's still
Digital.
ones and zeros. It's a digital signal. Digital is simply on or off. Nothing else to it. Do not overthink that, guys.
Okay.
All right? Now, question came up, okay, so what is analog? What is analog?
On and off?
That's digital.
Okay. Analog.
What's analog?
something you gotta do yourself.
So you have the program.
No,
It ain't
you
like a
use it every day.
remote.
You use it every day coming to work
Drive a car?
in more ways than one.
It's a program.
No, it's not a
Well,
program.
it's not a program, but how am I
Not a
about to
program.
put this?
What a thermostat on a wall. What is that?
It's a control. It's a
Uh,
control that,
it senses temperature.
It's analog.
when it reaches a certain temperature, it shuts it off or
Right.
turns it on.
It's 0 to whatever
Yeah.
its max is.
And
0
you're
to
talking-
100%.
And you're talking about a speedometer on a car.
Speedometer on a car, gas pedal. How fast do you go? 0 to 100 miles per hour.
Right.
Anything that has a scale
Is analog.
is analog. So, out on our lines, let's go back to our divider logic. So we have I's and O's. So here's our inputs and outputs. All right? So in order for the brain to work, we have to tell it something. We have to think something. All right? That's our inputs. Right? I'm inputting to my brain to take a step forward. Brain tells my body to move forward. All right? So we have to have inputs to tell the brain what to do to react. All right, so what's the reaction? That's the output. Remember, for every action,
That's a
there's a
reaction.
reaction. Are y'all with me?
Yeah.
Mhm.
When you go through and you see these two lines here, Guys, they are simply ones and zeros. This being a 1, that being a 0.
Open and close.
Open and close. Take that lightly, because in PLC terminology, this is
Yeah.
false. That is true. What?
Say again?
False
This
and true.
is false. That is true.
That's backwards.
No,
No.
it's not.
What do that false mean?
So y'all seen the computers up, and when you see the programs up, you've seen that some of these lines are highlighted. Y'all remember seeing those? When you see people looking at ladder logic and they're sitting there and they're going through the program, you see these things flash on and off. That's going 1 to 0, 1 to 0. This is a normally closed switch.
Right.
Okay? So which is gonna be a push button, right? It's either gonna be a push button, gonna be a toggle switch. Either way, it's gonna be something that's normally closed, just like on a set of points in a contactor.
Or limit switch.
Or limits, well, and normally open limits, normally closed limit
Yeah.
switch. So that's probably more like what it would be. This would be a normally closed, which is NC. But whenever you're looking at a switch or a relay and it's got NC on it, that means that those contacts are touching. Okay? This is a normally open. Now, when I said this is true and that's false, what did I mean by that? This is true because it's always live.
Yes.
This is false because it's not always live. It's open. This won't go true until somebody tells it to go true. You with me? You understand?
Mhm.
Okay? So, in order for this output to fire, both of these have to be in true state. What that's meaning is this switch has to be closed, this switch has to be open in order for that output to go high. When I say output's going high, that means that it's live. It's fixing to put juice onto whatever it is. So let's put this in relative perspective. This could be a disconnect. Disconnect always has to be closed in order for it to work, does it not?
Right.
It can't be open. It has to be closed in order for that to work. So that has to be true. This has to be open in order for it to be true. So let's say this is a push button. Your motor's running. All right? Right now your output is live. Your output's high. All right? Somebody comes in and they hit a button. They close that circuit. Your output is now going to drop out because somebody made a false indication. Y'all see how this works? It always starts at rung 0 and it goes to infinity, guys. There's programs out there that have over 1 million lines.
Wow.
You go to a power plant, you go to a nuclear plant. Could you imagine the run size in that?
Or the space shuttles.
Yeah,
God almighty.
because all that's automated, guys, and it runs off of throttle level. Okay, so with that being said, for every action, inputs, there is an output, a reaction. Okay, you just gotta have something there to tell it what it is. So let's go to our filters, and this is all evergreen filters. This is gonna put this to life. All right. Y'all notice here, what's a PE? Simple abbreviation.
Photo eye?
Photo eye. Nice job. What's an LS?
Limit switch.
Limit switch. All right. What's a PS?
Pressure switch.
What's an LT? What's a TT? Guys, they're all out there.
Tabletop.
Temperature transmitter.
Okay.
Level transmitter.
Okay.
Everything in code, PLC, will be abbreviated,
Okay.
okay? And that's what they all stand for, all right? So when you look at a program, you're gonna have descriptors here. When you're looking at it, the printout, it's gonna have descriptors, and that's what they're gonna be. But that tells you, hey, I'm looking for a photo line, or I'm looking for a limit switch, or
Yeah.
I'm looking for a pressure switch.
Now, like, the level transmitter, it wouldn't be put like a LS in there?
No,
They don't use that for like
LS is a
limit
limit
switch?
switch,
Yeah, alright, yeah, I got you.
okay? So, let's put this to life. This program, and that can't be a program, let's put this to life. So, we have input 1.8, which is a photo eye, right?
Mm-hmm.
This photo eye has to be closed in order for what? What's it firing?
It's firing where that number 9 can work.
Hold on, I screwed you up. I screwed you up. There we go. What output is that firing?
What, 9? I mean,
6, 6?
8?
Is that a motor?
If this photo eye gets blocked, which makes that true,
Yeah,
this is already open because nobody's pushed a button, right?
yeah.
Mm-hmm.
What is that?
What is that gonna fire?
What?
That's output 6.6.
I'll put 6.6, whatever that is.
Break.
Zero.
Okay.
Oh, okay, that's 6.6, okay.
Y'all notice we went backwards?
Yeah,
Your flow is this way, right? Because this is the infeed of the filler.
Right.
But your photo eye is down here, but we're working backwards.
it's like photo eyes, sales tape, top foot running, because it's blocked.
Yes, because it's blocked. There again, an action makes a reaction. This photo eye gets blocked, which means the line is full, so it hits the brake to keep from overfeeding the filler. Perfect examples, all your jug lines, guys. You have a photo eye that's doing what? Controlling brakes to keep the line pressure off of what's ahead of it.
Keep it from crushing the bottles.
Keep it from crushing the bottle.
Automation.
Automation, all right? This is exactly how we're set up out here, guys. Now, this is the infeed of the filler, right? This is the little worm screw, okay? If this eye blocks, what output am I gonna fire to stop my infeed, or my infeed? It's marked up there. What output am I gonna fire?
Say that again?
That's gonna
Three,
be
If
one.
this limit switch
2-4,
closes,
Yeah.
2-4,
because there's product blocking that eye,
Mm-hmm.
what output is it gonna fire?
0-2-4.
0616.
Zero's your output and it's 2-4.
So it's
It's a
not
3-1.
zero, that's O, guys, just
Yeah.
FYI.
Okay.
Anyway, cause your 1-3 is the input on the same line, I can't read the what's in the middle square. Time on.
So that's a timer bit.
Yeah.
So 2-4, two things you gotta look at here. It has to be 2-4 because output 6-6 is the brake. The only other output you have is 2-4. So yes, this is output 2-4. So whenever this limit switch gets made, it fires that output, which stops the infeed to keep from crashing the filler. Why? Because your exit conveyor is full. Now, why do y'all think I have a timer here?
It has to be blocked for so long
Why?
before it shuts it down.
Why?
In case
The ball start moving.
the carton or whatever there kinda hangs up, then it moves out of the way.
Nope,
Too much pressure?
nope. Why is there a timer there, guys? Think about what's fixing to happen. You got bottles going in front of this limit switch. So every time a bottle goes by, we're gonna shut off the infeed?
No.
No.
It has to be blocked for a certain amount of time.
Let's see what's
Hey.
going on.
Right.
Hey, remember when we did that photo eye down there on number 5, and I sped it up, cause it was jerking that night, every time ball went through. That's what I did.
That's why you put a timer in here. It has to be blocked for 3 seconds before it fires that output.
Right. That's what we got on the case washers up there for the
You got them
horn.
everywhere.
Yeah.
Okay,
All your photo eyes, most of them won't have timers on.
okay.
Y'all will never see those. They're internal to the program. I'm just letting y'all know. If you go up and you block an eye and it reacts 3 seconds later, that's why. It's not that there's nothing wrong with an eye. It's because there's a timer in there.
Kinda like your fill eye, got a timer on the N8s. It don't fire exactly when that carton does, cause there's not a carton underneath your fill, it knows.
Yeah.
It takes so many cranks to get there, and then it gonna
Yep.
fill.
So now,
In the midst of the carton, then it won't pump that time, then it'll go back.
any questions? Does that give y'all a little enlightenment on how things actually work out on the floor?
Yeah.
On how the conveyors actually work, how the fillers are actually starting and stopping on their own.
Yeah.
So if we doing a diagnostic or we doing troubleshooting on that, I know we can't see the internal of the PLC, but this will help us on the points where we can check and see if we getting the feed that we supposed to feed, right?
Yes, so here's what this does. The fact that y'all are learning this, it should make y'all start thinking about when you get called out to the N8, and let's say the in-feed line, let's say the side tube belt won't turn on. Or let's do even better than that. Let's say that it won't feed cartons. Your work plate won't pick cartons. Everything's running. Lines 2, 3, and 4 are running, but line 1 will not pick a carton. It should make you start thinking about, okay, what will keep line 1 from coming on? There's several things in the program that will keep it from coming on, but don't think of the program, because the program is only doing what we tell it to do, which means there's something physical telling that work plate not to run. Safety eye. It could be
Yeah.
that the photo eye at the top where the carton's going to the
Right.
mantle. What happens if that photo eye is blocked or is out? Will that work plate run?
Nope.
It shut off both lines on N8.
No.
No,
No,
one of
shuts off
them.
on
Usually that's why I tell them to wipe it off with a
Right.
paper towel or something.
Yeah, that's right, it won't that.
Yeah, it only shuts off at one line. Okay, let's say that, you're running fine and you're not filling. What will keep you from filling?
The filling,
The fill eye, which is
inside.
going off the chain. All right, there's always, guys, there's always an action. Don't make it hard on yourself. The program's doing what it's supposed to do. One thing you always remember, I don't care who tells you this, the program does not change unless somebody goes in there and changes it. It's been running for 10 damn years. All of a sudden it's not working? I don't think so, guys.
Right.
There's something that's telling that program not to start. Palletizer. We're out there trying to figure out what's going on with the proximity switch, right?
Mm-hmm.
There's something telling that machine not to start. There's something telling that machine to stop here. There's something telling that machine,
Yeah, last week when we were working on that, remember? It was the gate
yeah,
that was open on the side.
safety switch. There's
Yeah.
always something there, guys. It's nothing internal to the PLC. Okay, now, you can have a channel fail. Very far and few between. All right? Any questions on this, guys?
Yeah.
Everybody understand that? And don't get it all in. Don't even try to take it all in, guys. Just understand what you can, because we're gonna have more and more classes.
Okay, cool.
Now, how do we see all this? How do we know,
Schematics.
how do we know what this is doing?
From everyday reaction.
Not PLC.
No. How do we physically see what this is doing?
Not PLC.
No.
PLC, they put something.
PLC's, it's a computer, it's all in a chip.
Right.
It's gonna have to make it like numbers.
What is this?
HMI.
Stands for?
Um,
What's HMI stand for? You got it on all your pieces of equipment
Right.
that have a PLC.
It's,
Well, you have it on 90% of your equipment that have a PLC.
HMI?
it's the view, the program, is it,
Human machine interface.
okay.
This is your TV screens out there, guys.
Your touchscreens.
Your touch screens.
Okay.
Does it not, when you go up to the batching screens, do you not see temperatures and pressures and
Right.
flows and pump speeds and all that? That's what this is doing. That HMI is telling you what that program is doing. You go out to the palletizers or the wrappers, you get alarms flashing. It's telling you why the PLC does not start. Or why the machine don't start. That's the HMI. It's telling you what this thing is doing or not doing. Okay? Now, without this, you gotta use schematics. You can't do it any other way. Everybody understand that? You go to an N8, it tells you the temperature of your heaters. It
Right.
tells you how fast you're going. It tells you your airflows. It tells you your fill levels. It tells you everything.
Just a physical representation of
Exactly. It's a physical representation of what we cannot see. We don't care how it gets here, guys. Don't worry about it. Do not care about how it gets here. But you do want to look at that, because if it's telling you that, and guys, it does, you just got to look for it, that a photo eye is blocked. Go to that photo eye. Don't open the cabinet, there's no need. Right? Any other questions on that? Okay? Our next class on this will be on HMIs and how they work and how to read them, but it's gonna be on the floor. Well, no, it'll be in here because now I can get online. We'll show you how all that works on the HMI, and y'all like that. All right, so let's move to analog. So analog is 0 to whatever we need it to be at, right? Everybody agree with that?
Yeah.
Well,
So we have a thermostat. Does the thermostat go to 0?
no,
It depends on how the
On
thermostat.
a house thermostat. Does a house thermostat go to 0? No, where's it generally start out at?
probably 50 to 90.
50 degrees to, okay, let's say 90 degrees. Is that a problem because it don't start at 0?
No,
Why?
because it's all the way you got set up.
So when you're dealing with analog, you're dealing with two sets of numbers. Everything must relate to 0 to 100. It must.
And analog.
It has to have a start time or a starting place. It has to have an ending place. Okay? 50 equals 0. 90 will equal 100. Point being, let's go over here to a product tank. Guys, this is the way all your product tanks are set up out there and all your fillers. CIP tanks are the same. Well, no, they're gonna be different because they're actually digital. So, let's go with the N8. All right? You have an airline going to the product valve on the product tank, do we not? Just one airline, so we have.
Right.
No electrical, no nothing, just have the airline, right?
Right.
So how is it we're using that airline to maintain a level,
Level sensor.
which is what? So we have a level transmitter.
Right.
What's it transmitting?
It's signal.
Air signal.
How it's set up and is it in its range from 0 to 100?
He's right. It's measuring weight, it's measuring pressure. It's not measuring level. It's a pressure transmitter, is it not?
Right. But you say level because you said if you want to hear it 3 inches to 8 inches or whatever.
So our product tank is gonna be from 0, let's just say 20 inches. Make it simple. All right? Is that analog?
Yes.
Why is it analog?
It's analog
It's
because
a 0 to.
It's a range, it's got.
It's a range.
it's a
It
range.
has a range.
Okay.
Anything that has a range is analog, guys.
Okay.
Anything that is not on or off is gonna be analog. All right? So now we have to translate pressure to level. How do we do that? Well, by rule, in a tank or a pipe, doesn't matter, for every foot of product, water, milk, acid, the rule of thumb is 2.33 PSI per foot. We'll see where I'm going.
Mm-hmm.
Back here in the headlights.
I'm trying to figure it out.
Hey, James, I'm so sorry. Can I pee real quick? I
Yes,
gotta pee.
go.
Oh, hey, go ahead, go ahead, go ahead.
All right. So,
That's under one, right?
This
That's under one, right? Point is under one.
right, that's under one. So it's 0.233 PSI, guys. This is just a rule of thumb of what you
Right.
use. Rule of thumb. Acid will be different because acid is 13 pounds per gallon. All right. Water is 8.34. We are not figuring volume. This was a question that was brought up from the other side. We're not doing volume. We're doing pressure. We're doing the weight of that substance that's on a transmitter. The weight of that substance is 2.33 pounds per square inch for every foot of water. So for every foot, you have 2.33 PSI. So if I have 2 foot of water, what's my PSI?
Basically a half pound.
That's right.
Okay.
The taller it is, the more pressure you have with the bottom. Why do you think we have water towers throughout our cities? To maintain pressure in the system. That's why you have different heights. That's why some of them you have just tanks that are ground level, other ones you have elevated because of where they're at on sea level. It all depends on how much pressure you want on the system. Depending on where you're at sea level, if you're above sea level, it's on the ground. If you're below sea level, you gotta raise that tank to above sea level in order to maintain pressure. Same thing here, guys. Same thing here. Okay? So now, we wanna maintain 20 inches. So we're gonna take the 2.33, and y'all don't need to know this. This is
Okay.
just how it's done.
Okay.
We're gonna take that 2.33, put it over here in the processor. For every 2.33 equals 12 inches. 12 inches is what? That's a foot. So y'all see where this is going?
Right.
We want 20 inches, so we're gonna take, this, we're gonna divide it by 12. That's gonna give us the pounds per inch. All right, so let's do that. So 12 into 233, and we know it's point. So 12 going to 23, how many times?
2.
One time,
Oh, one
12,
time.
that leaves 11. Got to bring down to 3. 12 going to 113, how many times?
12.
10.
4.
11.
Uh,
We're getting close.
Just to make it easy,
Nine.
just to make it easy, we're gonna go 9. Just to make it easy, it's not right, but it's close.
Okay.
All right,
All right.
so now we're gonna take 0.0, because 12 won't go into 2, 0.19 times 20. So we're gonna bring the 0 down, that's 18, that's 4, that's 5. So for every 0.0580 PSI, it's gonna be 1 inch. So now our scale, our analog, now zero will always equal 0, well, no, 0 equals 0 here. And our scale is going to be 5.80 PSI. Because we changed our inches to pressure, which came out to, I'm sorry, my bad, 0.580, over half a pound.
Right.
So if you go over here, 2 foot is 0.466. Okay, so see how that's coming out? So that's what you make your scale to inside the computer. Y'all don't see that going on. Okay, so your pressure transmitter, which is we call a level transmitter. Why do we call it a level transmitter when it's reading pressure?
Because
So we're using it for levels.
Because
Yeah.
we're using it for a level. You can actually take that thing out and use it for pressure. All of your transmitters, all transmitters will have an analog, 0 to whatever, guys. Always. It's a transmitter. It's transmitting signal, not a signal, signal, which means it's a constant signal.
Okay, the transmitters that's in like filler 4 or 5, how would you tell what level it's supposed to be at, you know what I'm saying?
So whenever so look at it this way. So if we do ladder logic, this is gonna, don't let this bother y'all. This is just the way it's done. This is a binary. It's just internal. It's a programming thing. All right,
Okay.
don't worry about it. It's nothing y'all ever do. All right. What's gonna happen is this is gonna fire. That input has to fire, so that's your fill valve. You just took the switch, or you just hit a button and told that product valve to open up, I want to fill.
Right.
All right? You're going to have set points. PID, proportional, integral, and derivative. Don't worry about what they stand for because y'all won't ever use it. We will.
Mhm.
If y'all go to a class to learn PLCs and stuff, then yes, you'll use PIDs. But here, and we have them all over. They're on the N8s, they're especially in pasteurizing. They're all over the place. All right. A PID. So your P equals speed. Your I equals amount. Your D is not used for our purposes. Okay? So, this is what's going to happen. On a PID, you want to maintain, let's say you want to maintain 10 inches in this tank. That's what you want to maintain. So you have a set point. Set point equals 10 inches. Okay, we've already got our scale, which goes to 20 inches. Right? 0 to 20 inches. You with me?
Mhm.
Okay. Our PID is going to look for a set point, which in this case is 10 inches. There's going to be times when y'all call me, and I'm going to tell y'all to open up the PID. Next week we'll do HMIs. That way, while it's fresh on your minds. So I just made up my mind, we'll do HMIs next week. So that y'all understand what I'm doing with the PID. Okay? And once y'all do it the first time, you'll go back to it every time. You won't be afraid of it. All right? I'm going to tell you to go to the PID, and I'll show you where all that is. And I'm going to ask you what the P&I is. Most of the time, your P&I is less than 3. Most of the time, your I is less than a 4. It'll go up to 10. But what this does is, the higher the number, the faster it reads it. So, this is what a PID does.
What are you doing that on that spring press over there? On the grind call?
So you're gonna come in here, the purpose of a PID is so that it will maintain a level. Okay, so let's say when that valve is open 100%, you're putting in 15 gallons a minute. Okay, but runtime you're pulling out 12 gallons a minute. So can we always run with that valve all the way open?
No.
Why?
And they got time to fill up.
No, it's gonna overfill because
It's
you're
gonna
putting in
overflow.
more than you're taking out. So you have to maintain that, right? You don't want to take your valve and just open and close. Why don't you want to do that?
Because
Like in milk, like milk going into a filler, it's
It
gonna
make
fall.
a
It's gonna
foam.
foam real bad.
Because you open it wide open, it's shutting back off.
So the object is to get that valve to run at 12 gallons a minute. Maintain that level in that tank. So you want this line to be as straight as possible. Okay, so let's say we're set up, we're running. Y'all call me up and y'all say, hey, I can't maintain level, and I tell you I'm gonna go to the PID. And let's say you go there and the PE is set at 1.5. All right, so your sine wave, and you'll see this on the screen, guys. Is like that. If I tell you to go to a 2, what's that gonna do to the sine wave?
It's gonna get bigger.
What do you like? What's it gonna do to that sine wave? Remember, this is speed, right? This is how fast it's measuring. This is how fast it's
Yeah,
looking.
you're gonna get more ripples.
You're right.
Get more.
You're gonna get more ripples because it's looking faster. Okay? I is the amount. So we got I set at, say we got I set at a 2. And it's looking like that. All right, and I tell you to take it to a 1. What do you think it's gonna do now? Remember, this is how much it changes. So every time this reads, this is gonna change.
Right.
It's just the eye tells it how much it wants to change. Does it want to change from, okay, so here, this is pressure, right? Because we're running a valve. Y'all with me?
Mhm.
It's got airline on the valve, right? So we're measuring pressure. So let's say here, we're at 13 PSI. Okay? So your P comes in, it takes a measurement, it's at 13 PSI, but we're not keeping level in the tank, we're running out, so we need it to fill up faster. What am I gonna do with my integral? What does integral do? It changes the amount. So am I gonna take that integral up or am I gonna take it down? Thank you. So let's go from 2 to a 4. So I just went from 2, which is this, to a 4 because I'm not maintaining. And by going to a 4, what did I just do?
Increase the
It's gonna
amount.
get bigger and wider apart.
Now what am I doing? That valve is opening and closing. Why is the valve opening and closing? Because as soon as it opens, it fills up to 15 or 10 inches, I'm sorry. As soon as it opens, it goes to 10 gallons. As soon as it gets to 10 gallons, now it's gonna go to 0. Now it's gonna go back to 10. Now it's gonna go to 0. It's not maintained. The valve is open, closed,
Closed.
because I changed the amount of the valve open. So now I'm going from 13 to 20 PSI.
So the object is to keep it.
The object is to keep it as close to 13 PSI as possible. Keep it as close to 10, wherever I put it, inches.